All right, I'm trying to make sure it's recording though. All right, so here we go. Let's go ahead and get started here. All right, does everybody see my screen?
Mm-hmm.
Ready? Let me just show you what I did for this. All right. What I did here was this questions 1 through 10, or I will do together. And then the next worksheet is just kind of 1 through 10 repeated. And then on the next worksheet is the absolute value inequalities. And I'll just go through and do the odds, right? And then I went ahead and just, all right? So you can kind of double check your work as you're going. But the most important thing is obviously to show your work, or I can't give you credit for it. I don't just want the answer. All right. This week, we're working on quality. All right. The quality of the work is an important part. As I was telling some of the people earlier, next week I'm just going to do a chapter 1 review, and I'm going to probably treat it like a quiz, and then you guys can just work on it together if you want, or however you want to do it, and then submit it, and then I'll kind of go through and grade it. All right, and put a score on there. All right. But again, it's not supposed to be all that much stress. It's just to make sure that you guys are getting yourself ready for next year. All right, because you don't want to go behind. All right. So let's go ahead and just start with question number 1. These were called the compound inequalities. All right. Last time we did the inequalities. This time we're doing compound inequalities, which just means you have to solve inequalities. All right. So the first thing we're going to do is we're allowed to do mental math here. So we can just say negative 2x is less than negative 6. Remember, when you divide by negative, you change the inequality sign. So this would be x is greater than 3. All right. On the second part, we would say 4x is greater than or equal to 8. So x is greater than or equal to 2. Now I need everybody's attention because this is very hard. Okay. I'm asking you, what are the numbers greater than 3, or what are the numbers greater than or equal to 2? So I always tell my kids, generally, it's easier to look at this on a number line. All right. So if you look at it on a number line, here's 2, here's 3. Greater than 3 is this direction. And then we say greater than or equal to 2 in this direction. All right, now this note where or statement, it has to be true for 1, or it can be true for what? Both. So the questions are, what numbers are greater than 3? Well, it's easy to see that these numbers over here are greater than 3. And then you can say that all of these numbers are greater than 2. Well, if you recall, it only has to be true for one of the statements. So the correct answer is everything greater than or equal to 2. All right. Now again, that was the hardest concept we had last year. All right, which was tricky for a lot of kids. All right, so I'm expecting you, it is kind of a review, but I want you to get a message. I'm not sure. Now, we'll get to the end statements also, but right now, that would be a different answer if this statement wasn't. If it was an and statement, it would have to be true for what? It would have to be true for both statements. All right. Now, is everybody happy with number 1?
Yes.
All right. Assuming that's a yes. All right. Feel free to do that. Now, for question number 2, now we have an and statement. All right, so it has to be true for both statements. So we'll do the math here. right? If I move the 28 over, it becomes negative 25 is greater than 5x. Divide by 5. So again, remember when you reverse the order, x would be less than negative 5. Anybody have any issue with that? All right, over here, 6x is less than 18. So x is less than 3. All right, so I'm going to start asking you guys questions. I want you all to speak up. So to look up, speak up. All right, so I'm at negative 5 here. I'm at 3 here. If I am less than negative 5, I will be here. If I'm less than 3, I will be anything over here. So the question is, what numbers are less than 3 and less than negative 5? What numbers are less than 3 and negative 5? Anybody want to take a stab at it?
Negative infinity to negative 5.
Infinity to negative 5.
Okay. All right, I'm happy. Negative infinity to negative 5. These numbers over here are less than negative 5 and less than 3. These numbers right here are less than 3, but they're not less than negative 5. So they cannot be included in the solution because it is an and statement. All right? All right, that sounded pretty good, guys. Anybody have any questions? All right, let's move on. All right. Again, we can use math here. X plus 8 is greater than or equal to 20. X is greater than or equal to 12. Or 3x is greater than or equal to 21. X is greater than or equal to 7. All right, guys. What numbers are greater than 12 or greater than 7? Somebody jump in.
12 to infinity.
Somebody said 12 to infinity. Anybody else? Come on.
Yep. Yeah, 12 to infinity.
Yeah.
12 to infinity.
12 to infinity would be if it's an and statement.
To infinity?
You with me? So that would be if it's an and. Right now it's a what? Or. So it only has to be true for one of them. So again, just to show you how easy it is, on the number line, here's 7, here's 12. Here is greater than or equal to 12, and here is greater than or equal to 7. Are these numbers here greater than 7 or greater than 12?
Yes.
Yes.
Because it only has to be true for one of them. These numbers here are greater than 12 and greater than 7. So I agree with that?
Mm-hmm.
It's not an and statement, it's a what? It's an or. So now someone fill me in on the answer.
7 to infinity.
7 to infinity. Come on, guys. 7 to infinity. All right. Now remember, it doesn't really get any harder. All right. So if you're not understanding, it's much better to ask me now than to wait. Everybody okay with that?
Mm-hmm.
All right. Let's check out number 4 now. So again, the 7x is less than or equal to 7. X is less than or equal to 1. 15x is greater than 45, so x is greater than 3. All right, now they're in opposite directions. All right, so we have to really think about it. Right, let's draw the number line. All right, here is 3 and here is 1. Less than or equal to 1, greater than 3. So are these numbers right here less than 1?
Yes.
Yes, they are. All right, so that's okay. All right. Are these less than 1?
No.
Are they greater than 3?
No.
No.
They don't. Period. They don't count. These numbers, are those numbers less than 1?
No.
No.
Or are they greater than 3?
Yes.
So they, because it's an or statement, answer. So I don't know if you remember this, you would say from -infinity to 1 and from 3 to infinity. Although I did make one little mistake. That is supposed to be a bracket because bracket is inclusive. Anyone have any issues with that? Very good.
Yeah.
All right, here we go. Let's check out number 5. All right. Now, if you recall, this quantity is between 14 and 6. Right? So now, do this. I'm just going to show you all the steps. You would add to both sides of the inequality. And then you would divide by 4. So that means x is between 2 and 4. All right? X is between 2 and 4. Okay, guys. Anybody have any issues? This is like the only really hard topic to get with. All right, so I'm expecting you to say all right, number 6. Again, the important part is knowing this is an or statement. So 3x is greater than 45. So over here, I would have 3x is less than or equal to -45. So x is less than or equal to. So this one's a little strange. What greater than 15 or less than -15? Right? Again, it's hard for you to see, so I was told to just check it out. If I'm less than or equal to -15, I'm going this direction. Greater than 15, I'm going in this direction. So you should be able to look at that. Remember, now we're going from -infinity to -15. Now, made a mistake here, just to make sure this is an open parentheses, because it's, oh no, that wasn't a mistake, that's the wrong one. This is less than or equal to, so it's solid. This one over here is supposed to be open. Sorry about that. All right, so this right here is solid dot, union, and then open parentheses, 15 to infinity. All I want to do is this. Okay, so you guys are real quiet. I appreciate it very much. Is that explanation satisfactory with everybody? Anybody have any questions? You got to speak up. Don't be shy now. I can't really see. Okay. Everybody good? All right. We're good. Okay, over here, 13x is greater than or equal to 39. X greater than or equal to 3. Or 18 is less than 3x. 6 is less than x, or x is greater than 6. All right, so now you got to think about it again. I like to do the number lines just to make sure I don't make a mistake. Open circle going this direction, solid dot going this direction. Because it's or, it only has to be true for one of the statements. So the correct answer would be that. So we would say 3 to infinity. All right, hopefully, again, like I said, I'm not hearing any complaints, so hopefully we're doing well. All right, let's look at 8. All right, so here we go. 6x is less than or equal to 30. X is less than or equal to 5. X plus 5 is greater than negative 21. X is greater than negative 26. So what numbers are less than or equal to 5? And greater than or equal to negative, or just greater than negative 26. So it's everything what? Everything in between. So we would say parentheses, negative 26, 5, 5. All right, hopefully you feel good about that explanation. All right, let's take a look at number 9, kind of similar. So 2x is less than or equal to 14, x is less than or equal to 7, x plus 11 is greater than 12, so x is greater than 1. All right, so now here is 7, here is 1, greater than 1, less than or equal to 7. So it's everything between 1 and 7. Now 1 is a parentheses, 7 is a bracket. Okay. Number 10, all right, subtract 7. That's what I see. 4x is greater than or equal to 16. 4x is greater than or equal to 4. And if it's an or statement, so I'm less than 40. Oh, this one's the hard one. I think less than 48, greater than or equal to 4. All right, so I need everybody to pay attention on this one. The or statement has to be true for only one of them. So if you're less than 48, it could be any of these numbers.
Mr. Stroud, it says it's greater than 48.
Oh, thank you. That doesn't look right. Thank you. So they're both greater. Thank you. All right. So now if I'm greater than 48, 4 on the greater than or equal to 4. So that was easy. Would be anything greater than or equal to 4. All right, sorry about that. Everybody good with that?
Mm-hmm.
All right, so now your job is to do 1 through 10. 1 through 10 is the same as 1 through 10 up there. Just, okay? Now let's get to the absolute value inequalities. All right. Now, here I put them on a number line because sometimes I think it's easier to see the number line. But we can also do it in other directions. Let's do this. All right. Now, your absolute value inequality, we did this also last year, so it's not a big deal. All right. The rule was you set the absolute value, leave off the absolute values, just rewrite it as 6n is less than or equal to 18. Then you write it, but you change the inequality sign. The inequality sign is also changed from 18 to a negative 18. So I always try to make an effort to show kids solve an absolute value inequality. You first write it without the absolute value, then you change the inequality sign and the sign of the integer. So then from there, you just say n is less than or equal to 3. And over here we say n is greater than or equal to negative 3. All right, so if you're less than or equal to 3, and greater than or equal to negative 3, all right, your answer is just negative 3 to 3. Okay. So now for the number 3, same exact principle. M minus 2 is less than 8. and then minus 2 is greater than negative 8. So n is less than 10. N is greater than negative 6. All right, so here is negative 6. All right. Here is 10. Here less than 10. Greater than 6. So here we go. Negative 6 to 10. All right. Now we'll do greater than, so you can see the difference. Now here, though, you have to isolate the absolute value first, which means so the first the absolute value of x is greater than or equal to 6. When you write it without the absolute value, when you rewrite it, changing the signs. So now if you're greater than or equal to 6, if you're less than or equal to negative 6. Right, so from negative infinity to negative 6, union 6 to infinity. All right, how am I making sense, guys? Everybody? All right, here we go. Again, we isolate by moving the 3. So we say absolute value of r is greater than 5. So we write r is greater than 5. R is less than negative 5. Greater than 5. Less than negative 5. All right, so we say from negative infinity to negative 5. Union 5 to infinity. All right. Number 9, remember we have to isolate first. I got to get rid of this negative 5. We'll say absolute value of x minus 2 is less than 3. Minus 2 is less than 3. X minus 2 is greater than negative 3. X is less than 5. X is greater than negative 1. So if you're less than 5, greater than negative 1, that means everything between negative 1 and 5. All right, let's check out number 11. 1 plus 2 is less than 3. And 1 plus 3 is less than 3. 1 plus 3 greater than negative 3. So b is less than 2. B is greater than negative 4. Less than 2, greater than negative 4. So everything between negative 4. All right, data limitation is super important. Advanced math, we really don't know how many more. All right, you're just supposed to see that, but sometimes when you're the number line is helpful visually. Okay. So now it's moving a little harder. So now we say 10 p minus 4 is less than 34. 10 p minus 4 is greater than negative 34. 10 p less than 38. So p is less than 5. 10 p greater than negative 30. So p is greater than negative 3. Now, again, if you want to put that on a number line, you can. All right, but I don't really care about the number line. All right? I care about, do you understand that if you're greater than negative 3, you're less than 9.5. You should be able to see that right now. All right, any questions? All right, 15. Negative 8a minus 3 is greater than 11. Negative 8a minus 3 is less than negative 11. Negative 8a is greater than 14. So we'll switch the sign. Less than negative 7 fourths. And here, negative 8a is less than negative 8. A is greater than negative 1. Right? Now, here you have to understand negative 7 fourths is going this direction. All right, so you say from negative infinity to negative 7/4, union negative 1 to infinity. All right, anybody have any questions? All right, generally what we say around here are the hardest ones because you have to isolate first. All right, but because it's really good, if I add 10, that's 36. 36 divided by 9 is 4. So this problem is just the absolute value of n minus 8 is less than 4. Anybody have any questions with that? I think you guys can do the mental math of it. Add 10 divided by 9. All right. So then you would say m minus 8 is less than 4. M minus 8 is greater than negative 4. M is less than 12. M is greater than 4. Think about it. If you're less than 12 and greater than 4, you're everything between. You would say 4, 12. And if you have to use the line, you can. It's going this way, it's going this way. So you should see everything in between. All right, you guys. All right, 19. Again, adding 10 is negative 63. 9. So I have absolute value of r minus 2 less than negative 7. And everyone needs to put a little star by this one because this is where kids make just the silly mistakes. All right. When is an absolute value less than a negative?
Never.
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 So once you're in a hurry, they're just going to write out both equations, and you're going to go wrong. This is no solution. Right? If it were the absolute value of r minus 2 is greater than negative 7, number, because the absolute value is always greater than negative. All right? But here, I'll answer the no solution. The absolute value cannot be less than negative. All right, so let's take a look now at 1. Add 1, divide by 2. So 10b plus 7. 74 divided by 2 is 37. So now 10b plus 7 is greater than 37. 10b plus 7 is 37. 10b is greater than 30. So b is greater than 3. B is less than negative 44. So b is less than negative 22 fifths. All right, now you should be able to look at that and say, okay, that's greater than this way. Negative 22 fifths, I know then there's negative 4.5 right here, or 4.4. So again, we would just say negative infinity to negative 22 fifths. And greater to infinity. Is that good? All right, looks like we just have a couple more to go. Right. So isolate the absolute value, subtract 8, 16. 16 divided by 4 is 4. You should know that. 6 minus 2a is less than or equal to 4. 6 minus 2a is less than or equal to 4. 6 minus 2a is greater than or equal to negative 4 is less than or equal to negative 2. Okay, now remember, here's where mistakes are made. A is greater than or equal to 1. If we divide by negative, we change the sign. Negative 2a is greater than or equal to negative 10. A is greater than or less than or equal to. Again, if you're greater than 1 and less than 5, greater than 1 and less than 5, you make the difference between them. Right? Last one for today, guys, I think. Yep. Last one. Okay. Here's what I'm going to do. All right, subtract 3, divide by 4. So now absolute value of 3x plus 7. That's subtract 3. That's negative 92. Negative 92 divided by 4 is negative 23. Uh-oh. What do we got here? We got an absolute value greater than a negative. What is
All
it?
real numbers.
Very good. We're just going to read to infinity. All right. So again, you just have to be careful on the ones that are greater than a negative. If they're greater than a negative, it's always true. If they're less than a negative, they're never true. Okay, guys. Feel good about that. I'm hoping that was clear. I hopefully feel like you could ask a question anytime, just like in class. Everyone's kind of quiet. I know it's a review, but it is super duper important. All right, you're going into Algebra 2 next year, and if you're going to the IB program, this will really put you ahead. And those of you guys who are going to private schools, you're going to be having to take a test. All right, and your test is going to have this material. All right. After we finish chapter 1, I believe chapter 2 goes into lines and everything there is to know about lines. So that's another really important chapter. All right. So does anybody have any questions before we close out? Nobody?
Mr. Stroud, wait, real quick. Could you go back to number? Wait, let me find it. Could you go back to number 5 of this this one?
Okay.
Perfect. Thank you.
All right. Anybody else? Come on, guys. Nobody has any questions. This did not take very long. I didn't think it would because I think you guys, after I show you a few examples, would be good. All right. Now, I don't think I didn't put any IXL up. All right. So what I want to do is, if you're having trouble, you can let me know in the chat, and I'll be happy to move on. Anybody have any questions?
Thank you.
All right, guys. I hope you all.
All
have
right.
All right. I'm going to post it on YouTube like I did before. So if you have questions you want to go back, you can do that. All right, brother. Okay, y'all.
All right.
You guys have a great day.
You too.
See you, Mr. Stroud.
Take care, guys.
Mr. Strauss, the homework is section 2? Or
Yeah, just finish this worksheet, buddy.
okay.
All right. Everybody, all you have to do is finish this worksheet. That's it.
Yeah.
Take a minute.
Bye.
All right. Take care, guys. Thank you. Thank you. Have a great day.